Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So this is another lecture from the Strivers A to Z DS course. Just in case you're for the first time here, this is world's most in-depth course when you talk about DS Algo. Why do I say that? Because this course has 455 modules. By the end of the course, you would have solved more than 400 plus problems when it comes to DS Algo. You can go over the entire internet. You can buy any of the paid courses. None of them will be teaching you DS Algo in such depth. Something that I can give you as assurance is, if you complete this entire course, you'll be able to do any of the DS algorithms in any of the companies in any part of the world. So till now we have covered up till this particular problem, and this video I'll be covering up the problem 4 sum. But please make sure that you go and watch 3 sum before doing the 4 sum, because it's important you know how to do the 3 sum, and then only you can move across to do the problem 4 sum. So what does the problem actually state? It states that you'll be given an array and the array will be containing integers. And you have to find me 4 different indexes. Very important, you have to find me 4 different indexes such that if you sum up the numbers at those indexes, you'll be getting the value target. So let's take an example. This is an array and I've given you the target to be 0. The target can be any integer. Now the target over here is given as 0. You have to find me 4 different indexes. Now, for an example, I say, okay, let's pick up this, and let's pick up 2 and this. So if I pick up this, what I'll get is this quad. If I add up all the numbers, the summation is equal to 0. Now, I picked up 4 different indexes whose numbers on summing up gives me this value target, which is as of now 0. Now, can I pick up this? I can also do this 0 minus 2. And then I'll get this particular code, which will give me the value equal to target. I can also pick up this one, which is like minus 1, 1, 0, 0. And I will have this one. So, can I pick something like this? Maybe 0, minus 1, 1 and 0. It is equivalent to this because ultimately the indexes that you've picked up are same. So, you have to make sure that the 4 indexes that you're picking up should always be unique. And you have to return me all the unique codes that can give you the target when you sum them up. That is the question. So what is the first solution that you'll give to the interviewer? That is definitely the brute force solution. And what is the brute force? It is the extreme naive that you can think of. And if you have to generate the quads, that means 4 numbers. You have to try out all the quads. So what you can do is, you can try out all the quads, and whichever quad is giving you this particular target, you can store it. Similar to what we have done in 3 sum. If you remember, in 3 sum, there were triplets. And I used 3 loops, I, J and K, in order to generate all the triplets. So if you are looking forward to generate all the quads, the loops will be I, J, K and L. And this will make sure that all of the quads are generated. And then you can store all of the unique quads in a set, and then you can return the answer. Got it? So let's quickly code this up. So you can find the problem link in the description. Please do make sure that you try out the problem from the link in the description itself. So the first thing that I'll do is, I'll figure out the size. And this is how I can do it. Next, I will require a set which stores all the quotes. And right at the end, I'll be requiring a list, which will be taking everything that I've stored in that set of list, and I'll be returning it. Perfect. This is what I will be doing. I know that. Now, what about the 4 for loops? That's 0 till n. And the second element can be considered as J. So let's go ahead and do this. The third can be considered as K. Written down all the 4 for loops. What is the next thing? I'll require the sum. So maybe I'll take long because there are 4 numbers. They might just exceed. So it's like nums of I plus nums of J. And then I'll say sum plus equal to nums of K. I could have written it in a single line as well, but I don't want it to exceed the integer limit. So that's why what I've done is I've gone ahead and written it like this. Because if I write nums of I plus nums of J plus nums of K plus nums of L, it might exceed the integer limit and then the typecasting will fail. So please make sure first you add it up, then you keep on adding 1. So this is done. I know one thing for sure. If the sum is equal to target, this is one of my codes. And I can definitely store it in a temp. So let's quickly store it in a temp, which will be nums of I, nums of J, and nums of K, and nums of L. Perfect. This is something which I've done. And now I know one thing for sure. This will be sorted. So let's quickly sort it up. Once I've done this, what is the next thing that I'll do? I'll definitely put it into the set. Perfect. Because it is sorted similar to the threesome. And perfect. And once I've done this, I can say we have generated all the ports. We have stored all the uniques. And now we can definitely return the answer. So let's quickly go ahead and run this and see if it is running fine. Okay, there was an issue because we have to add hash include. Please go ahead and add hash include. I'll not go ahead and submit it because we're running 4 for loops. So what will be the time complexity? We know, all of us know. The time complexity will be big O of n to the power 4. What about the space complexity? We're using a set data structure and we're using a temporary array to store the ports. But that is just taking a size of, like this is just taking a size of 4. So that is as good as constant. We're using a set data structure which will be taking number of codes, right, into 2, one in which you store the answer and return. So this is the time complexity and the space complexity. Obviously, the interviewer will not be happy because you're using like n to the power 4 and I'll ask you to optimize this. This is when we will move to the better solution. So we have to optimize n to the power 4. And if we are optimizing n to the power 4, that will be somewhere taking it towards n to the power cube. Why it is n to the power 4? Because we are running 1, 2, 3, 4 for loops, correct? So we have to kind of trim down on the last for loop. Then only we will get 3 for loops. But then how do I manage the last one? That's very simple. What I will do is, I'll be like, okay, if I have to say, what is the last element? Number of at the index L. Can I write that as target minus nums of I plus nums of J plus nums of K? Can I write this as something like this? I can, because that is what this one will be. So can I run now 3 loops for I, J and K? If I run it for 3 loops, I will generate all the possible triplets. I'll generate all the possible triplets. If I'm looking for the 4th, I know the 4th value will be target minus this. And I can easily look up for that value on the array. Let me give you an example. Imagine I pick up, target is 0 over here. Imagine I pick up 1. Imagine I pick up 0. Imagine I pick up 0. So basically what I did was I picked up this, I picked up this, and I picked up this. Okay, so what I'm saying is I is standing over here, J is standing over here, K is standing over here, hypothetically. So I picked up 1, 0, 0. What is the summation? The summation is 0 minus 1. So you're looking for the 4th value. The 4th value is nothing but minus 1. What you do is you look for minus 1 in this particular array. Yes, you go and look for minus 1 in this particular array. And what you find is, hey, we have a minus 1. So we say, okay, this will be my L. This will be my L. This can be my 4th variable. Similar thing, if you remember, we have done in the 3-sum as well. If you remember in the 3-sum problem, what we did was we tried to keep I and J as constant, and to make sure that the duplicates are not taken, we just inserted everything between I and J to this particular hash set, if you have seen the video. And then we figured out for this one and this one, we had minus of array of I plus array of J, which is minus 1, which is plus 2. So plus 2 was already there in the hash set. So I can take these 3 triplets, and if you sum them up, you'll actually get 0. So we did a similar thing. So we can do a same thing over here. We will run a loop for I, J. We will run a loop for K, and everything between J and K. Very, very important. Everything between J and K will go into the hash set. Why not from outside? It's a very simple reason. Why not from the outside? I'll tell you. So I'll give you an example and I'll explain. Why not the entire array? Okay, let me give you an example. So I have changed the array a bit in order to explain you why it is very important to make sure that you do not look over the entire array. So imagine your I is over here. Okay. Imagine your J is over here. And imagine your K is over here. Just for a hypothetical assumption. And your target says, your 4th element, or let's say num of L, which you're looking for, because you've just taken 3 variables. Says target, which is 0, minus num of I which is 1, num of j which is -1, num of k which is 0. So what is the ultimate value? 0 minus cuts off 0 which is 0. So you're looking for a value 0. And if you look on the array, you'll find a 0. But what will happen is, we'll end up picking up the 0 at this kth index. And if you remember the condition, it clearly stated all should be distinct. So that is why what we will do is, instead of doing this, like looking on the entire array, we will first keep a I over here. And we'll keep a j over here. Okay. And then we will start a k over here. And then we will take a hash set, similar to the 3-sum. And after that, I'll be like, okay, this is I, this is j, this is k. Is there anything on the hash set? And then we will start moving the k. The moment I move the k, I'll take up -1 and I'll put it into it. And then I'll start checking this plus this plus this. And whatever is the fourth element, is it in the hash set? Once it is done, I will move it. But before that, I'll put it and then I will move it. So what is happening is, everything between j and k will be there in the hash set. And eventually I will try out everything. Pretty much similar to what we did with 3 sums, better approach. But over here, it is for 3 variables. So we have to make sure that everything between j and k, the last and the second last variable, goes into the hash set. I hope you understood that. So I've gone back into the code editor. Again, the problem link will be in the description. I have 3 loops now. I have everything same. And what I'll do is, I'll just declare a hash set. Okay, let's declare a hash set. And now I'll say, when I go ahead, I'll just insert this element nums of k. Okay. And over here, what I'll do is, if I'm over here, I'm looking for the fourth. So maybe as of now, let's keep it as long. That's a better way. And maybe let's keep this because we are summing up a lot of elements, so we never know. So the fourth element will be nothing but target minus the 3 elements sum. So maybe I can again take it as nums of I plus nums of j and then sum plus equal to nums of k. Perfect. And now what I'll do is target minus sum. Correct? And I will be like, hey set, which is on the hash set, can you find out fourth if that's not equal to the end, which means it is in the set. If the required fourth element is in the hash set, what I'll do is I will declare a vector of temp again, and I'll put all of these elements, which is nums of I, nums of j, nums of k, and the fourth element. But please make sure you typecast it to integer because the vector will be of integer. And at the end, please go ahead and sort this particular thing. Let's quickly do it. Sorted. Once you have sorted it, what is the next job? Yes, your set will be storing this. So go ahead and ask your set to store it. Once you've done it, you can go ahead and return it. So let's quickly run it off and see if it is running fine. Should be. It does. Let's quickly submit it. What is the time complexity? 3 loops for sure. N cube. And then we're using a hash set. You can say that it is logarithmic of n, or you can say it is big O of 1 if you're using an unordered set. So it will depend on what kind of set you're using. So I can say the time complexity is n cube into logarithmic of number of elements in the set, which might vary every time because sometimes there might be 1 element, sometimes might be 2 elements, sometimes might be 3 elements in the hash set, because as much as this increases, the number of elements in the set will increase. So this n will be a variable quantity. And then there's a temporary array which is a big O of 4 size, which is as good as constant. So let's not take it. What about the space? We're using a set data structure internal, which is at max might end up storing all the elements for once. So I can say it's a big O of n for the internal hash set, which is going to store all the array elements. And big O of the number of cohorts into 2. So for the unique and for returning the answer. So this is what we'll require. This will be the space that I'll require to store the uniques in a set, and 1 for returning the answer. So I can say this is my time complexity and space complexity. So over here, the interviewer will not be happy with 2 things. One is this extra hash set that they are using to look up in the array. The second is, in order to store unique, we're using a set data structure which stores all of these things. So he'll ask you to eliminate this. That is when we move to the optimal solution. So we need to get rid of two things. One is the hash set that we were using to look up in the array, and the other one is the set data structure that we were using to store the unique codes. How can we get rid of both of the things is the question over here. So something we know for sure is we have to run 3 loops, and we need to get rid of these two things somehow. How did we do that in the 3-sum problem? If you remember, what we did was we had an array, correct? And we knew one thing for sure, that the set that we were using to make sure that we have all the unique codes was actually storing everything in form of list, and everything was sorted. So the first thing that comes to my mind is, in order to have the looping correct, in order to have the uniques, I will first sort the given array. Whatever array is given to me, I'll sort it, because I don't want duplicates to be there. So I'll sort it. That's the first thing. And we did the same in the 3-sum as well. We will try to sort it in the 4-sum as well. So let's quickly sort it up. So what I've done is I've written a sorted array for you. Over here the target is 8. But what did we do in the 3-sum? I know that there were 3 loops, and we were looking for 3 elements in the 3-sum. That is something we knew for sure. So what we did over there was, we kept I over here, like in the sorted array. This is not the sorted array. In the sorted array, we kept I over here. We kept J over here, if you remember. And we kept K over here. And then we kept on moving J and K. Till we figured out that nums of I plus nums of J plus nums of K is equal to 0. That is what we did. We kind of used a 2-pointer technique in the 3-sum approach. Over there, we fixed I. If you remember, we fixed I. Over here, there are 4 elements. That is like I, J, K, L. We need to figure out 4 elements. So what I will do is, I will try to fix 2 things, because I need to run 2 pointers. So how can I run 2 pointers? By using 2 variables. So if I run by 2 variables, how many will go constant? 2. So what I'll do is, I'll fix I, I'll fix J. Simple as that. And next, I will say my K will be here and my L will be here. So I'll go ahead and do this. What after that? I'll just apply the same logic that I've applied. So as of now, what do I know? I know 1 plus 1 plus 1 plus 5. Does that make sense? Because this plus this plus this plus this. What is the value? 5, 6, 7, 8. Yes, we got an 8. We got an 8. And that is what the code was requiring as the target. So this is one of my possible codes. And if you carefully see, it is already in the sorted order. Next, I have taken this. So I have to move forward. So I'll try to move forward. I'll just move the K one step. And I will move the L one step back, because there's no point in taking the same variables. What about the next? We have a 2, we have a 5. But shall I take this 5 is my question. Because what I've done is, I've already done with this 5. So I've already used 5 to get an answer. And when I used 5, I required 1. So I know one thing for sure. If I use this 5 and I use this 2, I'll never get an answer. Because for 5, I have to require 1. So there's no point in using 5. So I'll try to avoid the duplicates. So if the previous one was 5, I'll try to move a slightly ahead. So I'll move to 1 step. And this is where I'll stop. I'll skip all the duplicates. Similar to what we did in 3-sum. Next, we have a 2, we have a 4. So let's add it up. 1 plus 1 plus 4 plus 2. Does it give? It does. So one more quote. It's like 1, 1, 2, 4. Again in the sorted fashion. So we get it. Next, we will move it by 1 step. It's as of now move it by 1 step. K and L. K and N. So we have moved it by 1 step, but we see something. Even after moving it by 1 step, they are similar to the previous elements. So I'll try to move them as long as they are not constant. So till here, because all of them were 2, so I don't want to be at 2. All of them are like, this is equivalent, so I'll move. This is equivalent, so I'll move. So I'll end up being here. Sorry, my bad. I'll end up being what's happening? Okay, I'll end up being here. Perfect. I'll just erase it. Next, I'll again try to sum it up. 1 plus 1 plus 3 plus 3. Again, I get a quad. So 1, 1, 3, 3. Perfect. Next, I'll move K and I'll move L. The moment I move L, they're crossing. If they cross, there are no quotes, because if I remember, I fixed ij and I required k to be over here, l to be over here, because I'm making sure that elements are like this. I is always lesser than j, is always lesser than k, is always lesser than l. That's why the moment they cross, there cannot be any further quotes, because the sorted order will be distorted. So I'll stop. I got it. I got my 3 quotes. What is the next step that I'll do? I'll try to move this. Again, a very critical thing. If you're trying to move this, does it make sense to have the same points, because you are still having 1 and 1 and you already have considered it. So you'll try to move j till the possible point it is not possible. Till the possible place where there is no 1. So I'll move j over here. So please be careful. If j was here, in the next step, it will move to a value which is not similar to itself. So I'll move it to here. Got it? And similarly now, k will start here, l will start here, and we'll do the same thing. And eventually, j will go here. J will go here, j will go here, j will go here, j will go here, and j will go here. When j goes here, it ends. And then I shifts. Now, if I is shifting here, will it again start with 1? There's no point. Will it again start with 1? No point. Will it again start with 2? Yes. It will now start with 2. So this time I will be here and j will be here. Again, you'll start with k here and l here, and again do the 2 pointers. So just make sure that you ignore duplicates by comparing it with the previous. For I, you'll compare with previous. For j, will compare with previous. For k, you'll compare with previous. For l, you'll compare with forward. Quite simple. Pretty much similar to 3 sum. But over here, we have to make sure that there are 2 people who are constant. So for both of them, we have to check for the previous values. Got it? So let us quickly code the optimal solution. So if you remember, I always started from the 0 element. So we will start from there. And before doing for j, I know one thing. If I go back to the thing, if I was here, in the next move, I will be here. But this I will not be considered, because this one is similar to the previous. So I will just write simply if I is greater than 0, because if it is the first element, it will always be. And if nums of I is equal to nums of I minus 1, I don't do anything. I just say, hey, don't do anything. Go to the next. Continue to the next. Do not go down. Perfect. If it is not, then I will go to this. And this is where I'll start from here. So what will be the check for j? Because if you remember, when I was here, when j was here, the next step, it was never here. It was here. So I will never consider this, because this has already been considered. How will you make sure? So I know one thing for sure. For the first time, the j is considered. So I know one thing. If j is greater than I plus 1, that means it's not the first element. It's the second element. Then I start skipping the duplicates. So for the first time, I will end up taking these ones. But when j moves, then I'll start skipping, because it's equivalent to the previous one. So if it's not the first element, or you can probably write not equal to as well. If this is not the first element, and still nums of j is equal to nums of j minus 1, please skip. There's no point in doing for this. It's a duplicate. So in this way, I'll make sure that I never have any duplicates. Perfect. What's the next thing? I need to have 2 variables. One is the k, which always starts from j plus 1. One is the l, which always starts with the last index. Perfect. I know I'll always move till they do not cross. Let's move till they do not cross. What's the next thing? I know there will be a long sum. What will be the sum? So can I say the sum will be, again I'll write nums of I, correct? And I'll say sum plus equal to nums of j. And then I'll say sum plus equal to nums of k. And then sum plus equal to nums of, nums of l. Perfect. And then I say if this particular sum is equivalent to my target, not equal to 0, equivalent to my target. And in one case is equivalent to the target. So in our test case, we did not have an example where we did similar to the 3 sum, where if it is lesser, like if the sum is lesser than target, then you have to increase. So we'll always move in this direction. If the sum is greater than target, then you have to decrease. So we'll always move in this direction. I did not explain it because we have already done it in the 3 sum. That is why my focus was on keeping I and j constant and explaining you these couple of if loops. So this is one of the cases. What's the other case? Can I say sum is lesser than target? What if the sum is lesser than target? We move left because we have to increase the value. What if it's the other one? That if we decrease the value, so we move right. Simple. What if they're equal? That is definitely an answer. So vector of int temp can be said as nums of I, nums of j, nums of k, and nums of n. Perfect. What's the next thing? Do we need to sort it? No, it's already sorted, right? I'll just take it and put it into our answer. See, I eliminated the extra set data structure. And now, what is the next step? I'm done with this element. Let's move. I'm also done with this element, so I'll move. But now I have to make sure that I don't have I cross over all the duplicates. Like if I'm standing over here, I need to make sure I go over here because there's no point in taking this 4 again. So cross over all the duplicates. I'm like, hey, listen, if nums of k is still equivalent to nums of k minus 1, can you please move? Because I don't want to keep duplicates. And similarly, can I say if nums of maybe I will just pull this off a bit so that you can, if nums of L is equivalent to the forward, then also I'll move this backward. And over here, what I'll do is, I know I'll keep on doing this till k doesn't cross a cell, because there's no point in doing after that, and k doesn't cross a cell. Simple. This will make sure that we don't overflow at any time. Done? Everything done? Can I say I'm done with the answer? I think I am. Let's quickly submit this and see if it is running fine. So we're getting wrong answer. Why? Because we forgot one important step. Yes. Which is sorting it. So let's quickly sort it. So what I've done is I've gone ahead and sorted it. Now I'll go ahead and run it and see if it is running fine. It is. And now I'll go across and click the submit button to see if it is submitted. It is. So what is the time complexity? Can I say I am running like couple of loops? So that's a big O of n square for couple of loops. So what about the time complexity? Can I say I'm definitely running 2 loops for I and j? So that's n square. And then the k and l are running for the remaining part. So for the first time, when I is here, j is here, k is running for this entire thing. And then when I is here, j is here, k is still running. So it's going over and over for kind of a long part of the array. Big often. So can I say it's like into n? So thereby into n makes it big O of n cubed. Because at max, whatever you do, whatever while loop you're running inside, I don't care. Because when I and j is over here, you're moving through and you're moving through. At max, you'll visit every element once. At max, you'll visit every element once. So thereby big O of n, which is n cubed. What about the space? It's big O of number of quotes. But you're not using any space to solve the problem. You're using a space to return the answer, nothing to solve the problem. Please make sure that you mention that to the interviewer. And going back to the problem, I can say that 4 sum is done as well. I hope you've understood the brute, the better, and the optimal. Just in case you've understood everything, please do hit that like button because it won't cost you anything, but that will highly motivate me. And if you haven't followed me on Instagram, what are you doing? You're missing out on a lot of informative content. So do follow me on Instagram. And if you're new to our channel, please do consider subscribing to us. And yeah, with this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye. Take care.
Whenever your heart is broken, don't ever forget you're golden.